Hey, Miller feller, what are you doing now? Moments ago you had a chainsaw in your hand, and now you've changed roles and you're doing something else completely different. Well, yeah, boss. I just got the delivery of a new heat pump. That's this afternoon's project, is to try to figure out how to install a heat pump. A heat pump? What's a heat pump? Educate us on heat pump technology. You're really getting into a lot of different technologies, Miller. I didn't expect you to understand because you're a boss man in the woods, in the woo. 12,000 BTU heat pump. It's called a mini split. So the big section sits outside, the compressor sits outside, and then in the room there is a unit that does the heat transfer. And This is a fairly good efficiency for 2022. It's a 22 SEER and a 9.5 HSPF, which is the heating efficiency, which is pretty good. There are plenty of good videos and tutorials on how to do a mini split installation when everything goes according to plan. Here I want to talk about a couple of areas where I had problems and how I resolved them. First was just the installation of the unit inside the bedroom in this case, some mechanical dimensional questions and watch-outs and gotchas that I covered. And then a more important one relating to the plumbing fittings and the poor quality in one case of a preformed flare and the implications and how to solve that problem. Apparently a relatively common problem, but be prepared on how to do it and have the right equipment. So let's go over. The first thing was relating to the installing of the head unit in the room where the heat pump is going to be used. In this case, it's more vendor specific, so there were some inconsistencies on the dimensions of the drawings provided, and relatively straightforward, but just need to be thinking about all the moving parts and how things interact. In this case, finding the studs forced the location of the mounting bracket, but the unit itself can slide around within the mounting bracket, which is great, but you have to anticipate this and adjust the position of the hole in the wall for the plumbing to go through. So relatively straightforward. The next one was more serious. Looked at the flares on the pipe fittings coming from the straight out of the box from the supplier, and noticed that one of them had a scratch/dent in the actual flared area. I knew this was going to be probably a problem. The other ones looked nice and clean, so I marked that fitting, but went ahead just as the exercise of seeing what happens when you have a defective flare. And sure enough, it leaked and couldn't hold a vacuum. Well, it could hold a vacuum shortly, but within an hour it had leaked up. So I actually pressurized the system and was able to, using soap bubbles and soap and water, see the leak quite explicitly at the expected point. Other areas were fine. So I had anticipated a problem and got the right equipment to cut the defective flaring off and do a new flare with a flare tool. That's what I had to buy, but I bought that ahead of time. And sure enough, after replacing that flare, the piping worked fine. So those were the two areas I ran into. And the installation, besides that, went really well. And again, just you have to anticipate there could be problems. And by anticipating them ahead of time, you're in a good position by having the right tools in place. If you don't need to use the tools, that's great. You can return them. But if you do need the tools and you don't have them, it just puts a big delay in the whole project. So plan ahead for known difficulties. Plumbing joints, electrical is usually not so much a problem. look at all the parts before you do the installation. In my case, I wanted to go ahead and install just to see what it would run into. But again, I had to do the repair. So save a lot of save a lot of money by doing DIY. Do a good job, and not for the faint of heart, but worked out really well.